What if the way we think about dieting today is not a natural extension of biology, but a misunderstanding that has been building for centuries? When most people hear the word diet, they think about restriction, weight loss, and discipline. But historically, the word meant something very different. It came from the ancient Greek word dieta, which referred to an entire way of living. It included food, movement, sleep, habits, and balance. In ancient medicine, especially in Greece and Rome, diet was not about shrinking the body. It was about maintaining harmony within it. Physicians like Hippocrates believed that food could influence bodily functions, mood, and disease. They observed patterns between eating habits and health outcomes, long before laboratories or modern chemistry existed. In that time, food was not divided into good and bad. It was considered powerful, but it was not feared. So how did we move from this balanced biological understanding of nourishment to a culture where eating became something to control and fight against? To understand that shift, we must go back to a time when survival, not appearance, shaped human eating behavior. If this video is helping you understand your diet in a new light, take a moment to like, comment, and subscribe so you won't miss the rest of this journey. For most of human history, food was not a moral issue. It was a survival necessity. Early humans lived as hunter-gatherers for more than 2 million years. During that long evolutionary period, our ancestors adapted to unpredictable food supplies. Some days brought abundance after a successful hunt. Other days meant very little food at all. Because of this pattern, the human body evolved systems that favored energy storage. When food was available, the body stored excess energy as fat. When food was scarce, stored fat was used to maintain vital organs and brain function. This biological design was not a flaw. It was a survival advantage. The human brain alone uses a large percentage of the body's energy, and glucose became one of its primary fuels. Our metabolism evolved to defend against starvation more strongly than against weight gain. That evolutionary history still influences how our bodies respond to food restriction today. When modern diets attempt rapid weight loss, the body often slows its metabolism in response. This reaction is not a lack of willpower. It is a biological defense mechanism shaped thousands of years ago. But something changed about 10,000 years ago that began to shift the human relationship with food forever. The agricultural revolution marked one of the most dramatic changes in human dietary history. Around 10,000 years ago, humans began cultivating crops and domesticating animals. This shift allowed for more stable food supplies, but it also narrowed dietary diversity. Instead of consuming a wide variety of wild plants and animals, early agricultural societies relied heavily on staple grains such as wheat, rice, or maize. Archaeological evidence shows that early farming populations sometimes experienced reductions in height and increases in certain nutrient deficiencies compared to hunter-gatherers. This suggests that while agriculture increased food quantity, it did not always improve food quality. Yet agriculture allowed populations to grow, and with growth came complex societies, written language, and eventually scientific inquiry. As civilizations expanded, so did early attempts to understand health through observation. Ancient medical systems in Egypt, India, China, and Greece all linked food to bodily balance. But without knowledge of cells, enzymes, or vitamins, explanations were often based on theories such as bodily humors or elemental balance. These early frameworks shaped dietary thinking for centuries. And even though they were incomplete, they laid the groundwork for something that would eventually transform diet into a scientific discipline. For much of recorded history, the dominant explanation for health in Europe was the theory of the four humors. According to this framework, the body contained blood, phlegm, yellow bile, and black bile. Health depended on maintaining balance among these fluids. Foods were classified by qualities such as hot, cold, moist, or dry, and were prescribed accordingly. While modern biology does not support the humor theory, it is important to understand that it represented one of the earliest systematic attempts to connect food with physiology. Physicians observed patterns and tried to build logical systems from them. Diet was considered a medical tool. It was prescribed for prevention and treatment of illness. What is striking is that weight loss was rarely the central goal. The aim was balance and function. The body was seen as something to regulate gently, not something to punish. However, as scientific tools improved in the 17th and 18th centuries, chemistry began to replace ancient theory. Researchers started to isolate components of food. They measured calories and identified macronutrients. Food was no longer only a part of lifestyle philosophy. It was becoming a measurable substance. And with measurement came comparison, ranking, and eventually judgment. The 19th century brought a major turning point. During this period, industrialization changed both food production and daily life. Urban populations grew, physical labor patterns shifted, and processed foods became more available. At the same time, early nutrition science was emerging. Scientists began identifying proteins, carbohydrates, and fats as distinct components of food. The concept of calories as units of energy was developed in the late 19th century. For the first time, food could be quantified in numbers. Around this time, one of the first popular diet books appeared. In 1864, William Banting published Letter on Corpulence, describing how he reduced his weight by limiting certain carbohydrates. His pamphlet became widely circulated and introduced the idea that body weight could be deliberately manipulated through specific food restriction. This was a subtle but important shift. Dieting was no longer only about health maintenance. It was becoming associated with body size. The cultural meaning of food began to change. Yet the biological systems that regulated hunger, metabolism, and fat storage had not changed at all. The body was still operating according to ancient evolutionary programming. And that mismatch would soon create tension between biology and expectation. As the 20th century began, scientific discovery accelerated. Researchers identified vitamins and discovered that certain diseases, such as scurvy and rickets, were caused by nutrient deficiencies. Nutrition became more precise and evidence-based. At the same time, new technologies such as household scales made body weight measurable at home. Public health campaigns began emphasizing calorie awareness. The idea that individuals could and should control their body weight gained momentum. But scientists were also beginning to understand metabolism more deeply. They observed that when calorie intake drops significantly, the body reduces energy expenditure. This phenomenon is known as metabolic adaptation. It means that prolonged restriction can slow the rate at which the body burns energy. This is not speculation. It has been measured in controlled studies. One of the most significant experiments in this field would take place during World War II, when researchers sought to understand the effects of starvation on the human body. The findings from that study would reveal something unsettling about prolonged dieting and its impact on both body and mind. The Minnesota starvation experiment, conducted between 1944 and 1945 under the direction of physiologist Ansel Keys, remains one of the most detailed studies on semi-starvation in healthy adults. 36 conscientious objectors volunteered for the study. After a control period, their calorie intake was significantly reduced for 6 months. The results were profound. Participants experienced weight loss, decreased heart rate, lowered body temperature, and reduced metabolic rate. But the effects were not only physical. Many developed intense preoccupation with food, mood changes, depression, and social withdrawal. These outcomes demonstrated that prolonged caloric restriction affects psychological health as well as physiology. When food intake was restored, metabolism gradually recovered, but the process required time and adequate nutrition. This study provided controlled evidence that the body defends against starvation through adaptive mechanisms. Yet despite this knowledge, dieting for weight control continued to grow in popularity in the decades that followed. Why did cultural pressure increase even as biological science revealed the complexity of restriction? The answer lies in social and economic shifts that reshaped how bodies were perceived. After World War II, many Western nations experienced economic growth and increased food abundance. Processed foods became widely available and affordable. At the same time, advertising industries expanded rapidly. Although our focus here is biological, it is important to note that environmental availability influences eating patterns. When high-energy foods are easily accessible, total calorie intake often increases. public health data began showing rising rates of obesity in the later 20th century. Researchers linked this trend to changes in diet composition, reduced physical activity, and urban design. In response, various dietary approaches gained popularity, including low-fat and low-carbohydrate regimens. Some were based on partial scientific findings, but many oversimplified complex metabolic systems. The human body does not respond to single nutrients in isolation. Hormones such as insulin, leptin, and ghrelin regulate hunger and energy balance through intricate feedback loops. Simplified messages about eliminating one nutrient often ignored this complexity. The biological system remained multidimensional, yet public advice sometimes became narrow. This gap between scientific nuance and simplified recommendation would shape the next phase of diet culture. By the late 20th century, long-term weight regulation had become a major focus of research. Scientists observed that many individuals who lost significant weight through dieting eventually regained it. Studies showed that after weight loss, levels of hunger hormones can increase while energy expenditure decreases. This combination makes weight maintenance biologically challenging. Researchers described this as a form of physiological resistance to weight loss. Importantly, this does not mean weight change is impossible. It means the body actively participates in the process. Fat tissue is not inert storage. It functions as an endocrine organ, releasing hormones that communicate with the brain. When fat mass decreases, signaling patterns change, influencing appetite and metabolism. These findings reinforce the idea that body weight is regulated by complex biological systems, not simply by personal choice. Yet popular discourse often framed dieting as a matter of discipline. This misunderstanding created tension between scientific evidence and public belief. And as research continued into the 21st century, scientists began exploring an even deeper question about evolution and modern eating patterns.
Modern evolutionary biology introduced the concept of evolutionary mismatch. For most of human existence, food scarcity was common. Today, in many parts of the world, calorie-dense foods are constantly available. Our genetic adaptations favor energy storage during times of abundance. In an environment of continuous abundance, those same adaptations can contribute to increased body fat. This does not mean that biology determines destiny. It means that our bodies evolved under conditions very different from the modern food environment. Understanding this mismatch helps explain why simple advice such as eat less and move more does not fully capture the biological complexity of weight regulation. It also reframes diet culture as something that developed within a specific historical and environmental context. The story is not one of personal failure. It is a story of biology meeting rapid technological change. And as we continue this documentary, we will examine how scientific discoveries, economic forces, and evolutionary history combine to create the modern landscape of dieting, a landscape that still influences how millions of people understand food today. One of the most profound discoveries in modern biology is the role hormones play in regulating appetite and energy balance. Hormones are chemical messengers, and in the case of eating, they are responsible for signaling hunger, satiety, and energy needs to the brain. Two of the most important are ghrelin and leptin. Ghrelin, often called the hunger hormone, rises before meals, signaling the brain that it's time to eat. Leptin, released by fat tissue, informs the brain about long-term energy storage, acting as a brake on appetite. Other hormones, such as insulin, peptide YY, and cholecystokinin, fine-tune digestion and hunger. When humans engage in dieting, these hormonal systems respond in ways that can make restriction challenging. Reduced calorie intake often increases ghrelin, making people feel hungrier, while leptin levels drop, signaling a need to conserve energy. This biological pushback explains why long-term weight loss is so difficult. The body is not simply ignoring your intentions, it is actively defending a set point that has evolved over millennia. Understanding these mechanisms is crucial, because it shows that the challenges of dieting are deeply rooted in human biology rather than personal weakness. And yet, despite this knowledge, 20th century diet culture largely ignored these internal signals in favor of prescriptive rules about what to eat. The 20th century witnessed a remarkable surge in popular diet movements, many of which were based more on trends and ideology than on rigorous science. One of the earliest was the Atkins diet, introduced in the 1970s by Dr. Robert Atkins, which promoted extremely low carbohydrate intake and high fat consumption. Its premise was that reducing carbohydrates would limit insulin spikes and therefore reduce fat storage. Around the same time, other diets, such as the Scarsdale diet, emphasized high protein and low calorie restriction. Meanwhile, low-fat diets gained traction following early research suggesting a link between dietary fat and cardiovascular disease. Governments and health organizations began recommending reduced fat intake for the general population. Many of these trends focused heavily on macronutrient manipulation rather than on understanding metabolism in the context of individual hormonal regulation, activity levels, or long-term sustainability. Despite variations, all shared a common feature: the promise of rapid weight loss through restrictive or prescriptive eating. This created a pattern of experimentation among the public, often without scientific oversight. And while some individuals experienced temporary success, the long-term outcomes frequently conflicted with our body's natural biological defenses, which had been honed over tens of thousands of years. Among the most heated debates in nutrition science during the 20th century were those between proponents of low-fat diets and advocates of low-carbohydrate diets. Low-fat diets gained massive popularity in the 1980s and 1990s, driven by studies that linked high saturated fat intake to heart disease. The message was simple: eat less fat to protect your heart. Food manufacturers responded with low-fat products, and public messaging reinforced the idea that fat was the enemy. At the same time, low-carbohydrate diets, such as Atkins or later ketogenic approaches, argued that reducing carbs could optimize metabolism and regulate blood sugar. Modern research now shows that neither extreme is universally optimal. Human bodies respond to macronutrients differently depending on genetics, activity levels, and hormonal regulation. Excessive restriction of one macronutrient often triggers compensatory mechanisms in appetite and metabolism. These debates highlight the complexity of biological systems, and why simple formulas such as cut fat or cut carbs are insufficient to predict long-term outcomes. But even as the scientific community refined its understanding, a new factor was entering the picture, one that would transform the relationship between nutrition and society: the commercialization of dietary science. The commercialization of nutrition science became a defining feature of the late 20th century. As food industries recognized the power of diet in shaping consumer behavior, scientific findings were increasingly used to market products. Research about calories, macronutrients, and vitamins became intertwined with advertising. Cereal companies promoted low-fat or high-fiber products as scientifically proven to enhance health, while supplement manufacturers emphasized nutrient deficiencies that could be corrected with pills. This trend blurred the line between evidence-based guidance and profit-driven messaging. It also created an environment where diet fads could spread rapidly, often without rigorous evaluation. For example, low-fat snack bars were marketed as healthy alternatives, despite being high in sugar and refined carbohydrates. The public increasingly associated dietary science with immediate results rather than long-term biological balance. This commercialization also reinforced a focus on appearance over health, encouraging the perception that certain foods were good or bad regardless of their physiological effects. And yet, despite marketing pressures, scientists continued to develop frameworks that could integrate metabolism, hormones, and evolutionary biology into evidence-based recommendations. Modern evidence-based dietary frameworks aim to reconcile the complexities of human biology with practical nutrition guidance. Researchers now recognize that no single diet fits all. Biological factors such as genetics, hormonal signaling, metabolism, and evolutionary adaptations must be considered alongside environmental and cultural influences. Concepts like energy balance, macronutrient quality, micronutrient sufficiency, and dietary variety are central to contemporary recommendations. Studies emphasize the importance of whole, minimally processed foods and the dangers of extreme restriction or obsession with macronutrient ratios. Additionally, clinical research shows that gradual, sustainable changes in dietary patterns are more effective for long-term health outcomes than aggressive short-term fads. Guidelines now integrate lessons from hormonal regulation of appetite, acknowledging that hunger, satiety, and metabolism are dynamic systems that cannot be ignored. This evidence-based perspective represents a shift from dieting as punishment to nutrition as education and support for biological needs. Yet even with these advances, diet culture has left lasting impressions on society, shaping perceptions and behaviors that persist across generations. This tension between biology and culture sets the stage for understanding the modern challenges of eating in the 21st century. Despite a growing body of evidence, contemporary society continues to grapple with diet culture. Even in regions with abundant food, the human brain still responds to cues for energy intake developed during scarcity. Processed and calorie-dense foods exploit these mechanisms, often leading to overconsumption and metabolic stress. Furthermore, long-standing diet fads have left psychological footprints: guilt, anxiety around food, and obsession with weight. From a biological standpoint, these reactions are understandable. The body evolved to defend against starvation, not to adapt instantly to unlimited abundance. Modern research highlights that attempting to override these systems through extreme restriction or rigid diets can trigger hormonal imbalances, metabolic adaptation, and psychological stress. Scientists increasingly emphasize approaches that respect biology, flexible eating, attention to hunger cues, and nutrient-rich food choices. Understanding the historical context of these biological processes sheds light on why diet culture persists, despite decades of scientific insight. But the story of dieting is far from complete. To fully appreciate it, we must examine how these frameworks intersected with broader public health policies and emerging global trends.
Public health initiatives in the late 20th and early 21st centuries attempted to address rising rates of obesity and diet-related disease. Governments, nutrition organizations, and medical associations released guidelines emphasizing reduced calorie intake, balanced meals, and regular exercise. While grounded in science, these messages often clashed with deeply ingrained societal behaviors and biological drives. For instance, campaigns promoting low-fat eating overlook the compensatory increase in sugar consumption, which could exacerbate insulin-related metabolic effects. In parallel, new research on the microbiome revealed that gut bacteria influence digestion, nutrient absorption, and even appetite regulation. This emerging evidence introduced another layer of complexity: food does not act in isolation. It interacts with the trillions of microorganisms inhabiting our digestive system, which in turn communicate with hormonal and neural networks to shape metabolic outcomes. The integration of microbiome science, hormonal signaling, and evolutionary biology represents the cutting edge of dietary research. Yet even as knowledge deepens, public messaging struggles to match this sophistication, leaving many individuals navigating a landscape shaped by biology, culture, and marketing forces. Another challenge of modern diet culture is the oversimplification of macronutrient debates. Low-fat, low-carbohydrate, and high-protein approaches are often presented as dichotomies: one is good, the other bad. Science, however, shows that outcomes depend on context. Protein intake, for example, is essential for muscle maintenance, hormonal function, and satiety. Carbohydrates provide glucose for brain function, and fats are vital for cell membranes and hormone production. Restricting any one macronutrient without considering individual biology can lead to deficiencies, metabolic stress, or compensatory changes in appetite. The human body operates as an integrated system, balancing multiple signals to regulate energy and nutrient intake. Recognizing this complexity is critical for creating evidence-based recommendations that are both biologically sound and practically sustainable. This approach also highlights why past diet fads, despite their popularity, often fail to produce long-term results. Understanding the interplay between biology and dietary advice illuminates both the promise and the limits of intervention. One of the most important lessons from historical and biological research is that sustainable nutrition depends on aligning eating patterns with human biology. Unlike early diet fads that promised rapid transformation, contemporary frameworks emphasize flexibility, nutrient diversity, and attention to internal cues. Hunger and satiety signals, hormonal feedback, and metabolism are treated as essential guides rather than obstacles to overcome. For example, meal timing, macronutrient balance, and dietary variety are designed to support energy needs while preventing the compensatory metabolic slowdown observed in studies like the Minnesota starvation experiment. This evidence-based perspective shifts the focus from short-term appearance goals to long-term health, performance, and cognitive function. By contextualizing diet within evolution, physiology, and biochemistry, scholars can appreciate why human bodies respond as they do to restriction, abundance, or imbalance. Yet even with this understanding, societal pressure, food availability, and individual psychology continue to create challenges. As we move further into this documentary, the next question arises: how did these challenges shape modern misconceptions and fears around eating? Cultural perceptions of body image and health are deeply intertwined with biological realities, creating a complex environment for understanding nutrition. Historical diet culture, combined with marketing, medical guidelines, and social norms, has shaped collective expectations about weight and eating. This can create conflict between the body's evolutionary adaptations and the mind's perception of what is healthy or acceptable. For example, hormonal systems evolved to maintain energy balance, but in a modern context of abundant calorie-dense foods, these same systems can contribute to weight gain, despite the absence of underlying pathology. Biological systems are finely tuned, yet public perception often oversimplifies them. Research now demonstrates that addressing metabolic health and nutritional adequacy requires a nuanced, multi-layered approach that considers individual variability, hormonal regulation, and microbiome interactions. By understanding both historical context and biological mechanisms, scholars can see why certain dieting strategies fail repeatedly, and why evidence-based, flexible approaches are necessary. The next phase of our exploration will reveal the evolution of public understanding in the 21st century, where biology, research, and global dietary patterns collide in unprecedented ways. Modern humans face what scientists call an evolutionary mismatch, a situation where our bodies, shaped over millions of years to survive scarcity, now exist in environments of constant abundance. For most of human history, high-calorie foods were rare and physical activity was unavoidable. Our genes evolved to conserve energy and store fat during times of plenty, because famine was always a looming threat. Today, however, highly processed, calorie-dense foods are everywhere, and sedentary lifestyles are common. These conditions trigger biological mechanisms that were once advantageous, but now contribute to weight gain, insulin resistance, and metabolic stress. Hunger and satiety signals, finely tuned for fluctuating food availability, can be overridden by hyperpalatable foods engineered to appeal to taste and reward centers in the brain. Even with conscious effort, the body's hormonal responses, ghrelin, leptin, insulin, work against rapid weight loss, explaining why many individuals struggle to maintain dietary restrictions. Understanding this mismatch is crucial for scholars, because it reframes diet struggles not as failures of willpower but as predictable outcomes of evolutionary biology. Yet recognizing mismatch is only the beginning. The next layer of complexity lies in the integration of hormonal regulation with the microbiome, which profoundly influences metabolism and appetite. The human microbiome, composed of trillions of microorganisms living primarily in the gut, has emerged as a central player in nutrition and health. Microbes assist in digesting complex carbohydrates, synthesizing certain vitamins, and modulating immune responses. Recent research shows that microbiota composition influences energy extraction from food, hormone signaling, and even appetite regulation through the gut-brain axis. For example, some bacterial species can increase production of short-chain fatty acids, which interact with hormonal pathways to influence satiety. Others may contribute to inflammatory responses when diets are high in refined sugars and low in fiber. This means that the biological response to any diet is not solely determined by macronutrients or calories but also by the interaction with the microbiome. Diets that ignore this complexity may inadvertently disrupt microbial balance, leading to unintended metabolic consequences. Scholars studying nutrition must therefore integrate microbiome science with classical hormonal understanding. These discoveries challenge simplistic approaches to dieting and show that our bodies are systems of interconnected biology, not machines that respond predictably to restriction. But even as biology becomes clearer, societal perceptions of food continue to clash with evidence, creating fertile ground for myths and misconceptions that persist into the 21st century. global nutrition patterns reveal just how complex the relationship between food and biology really is. Across the world, dietary composition varies dramatically, reflecting culture, geography, and agricultural practices. Populations in Mediterranean regions traditionally consume diets rich in vegetables, legumes, olive oil, and fish, which correspond with lower rates of cardiovascular disease. In East Asia, rice-based diets, supplemented with fermented foods like miso and kimchi, support healthy gut microbiomes and provide essential micronutrients. In contrast, industrialized nations consuming high amounts of refined grains, sugars, and processed foods experience rising rates of obesity, diabetes, and metabolic disorders. These patterns illustrate the principle that biology does not operate in isolation. Evolutionary adaptations, hormonal systems, and microbial communities interact with cultural food choices. Understanding these differences helps scholars appreciate why no single diet fits all populations. Evolutionary history provides context, but environmental and cultural factors determine actual nutritional outcomes. As we continue exploring, it becomes clear that early 21st century diet myths often ignore this complexity, perpetuating oversimplified advice that conflicts with biological evidence, and setting the stage for misunderstanding and frustration among the public. Despite advances in nutritional science, the early 21st century saw the rise of numerous diet myths, many of which gained popularity without rigorous scientific support. One persistent myth is the demonization of entire macronutrient groups, such as fats or carbohydrates, regardless of quality or context. Another involves the concept of detox diets, claiming that the body needs external interventions to remove toxins, despite evidence that the liver and kidneys already perform these functions effectively. Fad approaches like extremely low-calorie regimens, juice cleanses, or elimination diets often promise rapid results, but ignore hormonal responses, metabolic adaptation, and microbiome effects. Controlled studies show that such strategies can lead to temporary weight loss, followed by rebound weight gain, hormonal imbalances, and psychological stress. Importantly, these myths persist even among well-intentioned individuals seeking better health. The discrepancy arises from the lag between evolving scientific understanding and widespread public perception. Scholars examining diet culture must therefore distinguish between historical, biological, and socially constructed claims about food. Yet, as misleading trends continued, evidence-based approaches began emerging that integrated biology into practical, sustainable frameworks, offering a path forward that aligns with human physiology rather than against it. Integration of biology into practical long-term dietary frameworks represents a paradigm shift in nutrition science. Unlike restrictive fad diets, these frameworks focus on aligning eating habits with human physiology, including metabolic rates, hormonal regulation, and gut microbiome composition. Emphasis is placed on whole, minimally processed foods, adequate protein for muscle maintenance, complex carbohydrates for sustained energy, and healthy fats for hormone synthesis and cellular function. Importantly, eating patterns are designed to support satiety and prevent compensatory metabolic slowdown, recognizing the body's evolutionary adaptations to scarcity. This approach also accounts for variability between individuals, including genetic differences in nutrient processing and energy expenditure. Modern evidence-based guidelines emphasize flexibility, allowing adaptation to lifestyle, preferences, and cultural practices while still optimizing health outcomes. This balance represents the culmination of centuries of observation, experimentation, and discovery, from ancient Greek physicians noting food's impact on health, to contemporary research integrating endocrinology, microbiology, and evolution. And yet, even with these advances, human behavior, societal pressures, and environmental factors continue to challenge our ability to adhere to biologically appropriate dietary patterns, raising questions about how modern society can reconcile biology with the abundance and complexity of the food environment. A deeper understanding of biology highlights why metabolic adaptation complicates weight management. When calorie intake is significantly reduced, the body initiates a series of responses to preserve energy. Basal metabolic rate decreases, hormones such as leptin drop, and ghrelin increases, intensifying hunger. These adaptations evolved to protect against starvation in ancestral environments. However, In modern contexts, these mechanisms can undermine restrictive dieting efforts, leading to rebound weight gain and frustration. Evidence from longitudinal studies shows that these responses can persist for months or even years after dieting. Recognizing this, contemporary dietary frameworks advocate for gradual, sustainable adjustments rather than extreme restrictions. By working with the body's biology rather than against it, individuals can achieve better health outcomes and prevent the physiological and psychological consequences of extreme dieting. Yet, as scientists uncovered these mechanisms, the interaction between hormones, microbiota, and diet revealed an additional layer of complexity that traditional approaches failed to address, pointing toward a more integrative model of nutrition science. The gut microbiome further complicates the picture of human nutrition, as its composition can influence digestion, appetite regulation, and energy extraction from food. Diets high in fiber promote the growth of beneficial microbes that produce short-chain fatty acids, supporting gut health and metabolic balance. Conversely, diets high in processed sugars and low in fiber can shift microbial populations, contributing to inflammation, insulin resistance, and dysregulated appetite. Emerging research demonstrates bidirectional communication between the gut and the brain, affecting not only digestion but also mood, cravings, and hormonal signaling. This interplay suggests that sustainable nutrition must consider the microbiome as an active participant in energy homeostasis. Ignoring this system can lead to interventions that fail over the long term, regardless of calorie content or macronutrient distribution. Understanding the gut's role in diet bridges historical biological observations with modern molecular science, showing that human physiology operates as an integrated network rather than a series of isolated components. But even with this knowledge, translating these insights into practical recommendations for diverse populations remains a significant challenge. Global variations in diet underscore the importance of context in nutrition science. Traditional Mediterranean, East Asian, and Nordic diets demonstrate how regional food practices align with biological needs, supporting cardiovascular health, gut microbiome diversity, and long-term metabolic balance. Conversely, diets dominated by highly processed foods, refined sugars, and saturated fats often correspond with higher rates of obesity, diabetes, and cardiovascular disease. These patterns highlight that biology alone does not determine health outcomes. Environmental, cultural, and behavioral factors interact with evolutionary adaptations and hormonal systems. Public health guidelines now increasingly emphasize nutrient quality, dietary diversity, and sustainability over rigid calorie counting. For scholars, these observations provide critical insight into why certain diet strategies succeed or fail, and why oversimplified approaches often conflict with human physiology. Yet despite this understanding, misinformation persists, creating tension between scientific evidence and public perception, which continues to influence modern dietary culture and behavior in profound ways. Early 21st century diet myths continued to circulate despite mounting biological evidence. Popular claims such as all carbs are bad, fat makes you fat, or detox cleanses unnecessary often ignored underlying mechanisms like metabolism, hormonal adaptation, and microbiome activity. Rigorous studies consistently demonstrated that the body's response to food is multifactorial. Nutrient quality, timing, hormonal feedback, and microbiome composition all contribute to outcomes. Nevertheless, media simplifications and marketing narratives perpetuated misleading advice. Scholars studying diet culture must differentiate between biologically grounded guidance and myth, recognizing that human physiology cannot be overridden by ideology or fads. This distinction is critical for understanding how diet culture evolved from early historical frameworks to modern challenges. And as research increasingly integrates hormonal science, microbiology, and evolutionary biology, a more holistic understanding of nutrition emerges, offering pathways to reconcile ancient biological programming with modern dietary environments. The integration of biology into practical, long-term dietary frameworks represents the culmination of centuries of observation, experimentation, and scientific discovery. These frameworks respect evolutionary adaptations, hormonal regulation, and microbiome activity while accommodating environmental and cultural realities. They emphasize whole, minimally processed foods, nutrient balance, and flexibility in eating patterns, rather than rigid restrictions or elimination. Education about biological mechanisms, such as hunger hormones, metabolic adaptation, and microbiome interactions, empowers individuals to make informed decisions rather than chasing short-term trends. This approach reconciles historical insights, contemporary science, and practical application, demonstrating that sustainable nutrition is achievable when we work with our biology rather than against it. Yet, even as these frameworks provide guidance, human behavior and societal pressures continue to challenge adherence, illustrating that diet culture is not only a biological issue but a complex interplay of science, history, and environment. The next chapter of this documentary will explore how modern society, technology, and global food systems continue to influence human eating behavior in unprecedented ways, setting the stage for the final third of our story. The modern food environment is dramatically different from anything our ancestors experienced. Globalization, mass production, and technological advances have made calorie-dense foods accessible virtually anywhere at any time. Refrigeration, frozen meals, and processed snacks allow extended shelf life and convenience, but they also encourage consumption patterns that challenge our biology. Hyperpalatable foods, engineered to maximize sugar, salt, and fat, trigger reward pathways in the brain that can override normal satiety cues. Even with an intact hormonal system, humans often eat beyond energy requirements when exposed to such stimuli. Evolution did not prepare our bodies for constant abundance, and yet modern society delivers it in abundance. Additionally, global supply chains have homogenized diets, reducing diversity in many regions. Traditional eating patterns, shaped by local ecological and cultural factors, are increasingly replaced by high-calorie, nutrient-poor options. These changes influence metabolic health, gut microbiome composition, and even epigenetic expression. Scholars must recognize that modern food technology and global accessibility create a new biological context, one where ancient adaptations interact with unprecedented abundance. But while technology drives availability, social and cultural pressures further shape how people interpret and respond to food. Societal pressures and perceptions of body image play a profound role in shaping modern diet culture. Throughout the 20th and 21st centuries, ideals of beauty and health have shifted dramatically, often emphasizing thinness or muscularity over physiological well-being. Cultural narratives influence behavior, leading individuals to attempt dietary strategies that may conflict with their biological needs. For example, restrictive dieting to achieve a certain appearance can trigger hormonal changes, slowed metabolism, and altered satiety signals, making weight maintenance challenging. Even with knowledge of evolutionary biology or microbiome science, societal expectations exert significant psychological pressure. Studies show that body dissatisfaction and perceived social norms are associated with disordered eating patterns and repeated cycles of restriction and rebound. The tension between biological reality and social expectation has created an environment where diet culture is not merely about nutrition, but about identity, conformity, and perceived self-worth. Understanding this interaction is essential for scholars, because it demonstrates how external pressures can amplify biological responses in ways that complicate both health and behavior. Yet, beyond psychology, these pressures have tangible, long-term physiological consequences that cannot be ignored. Long-term adherence to restrictive or fad diets can have significant physiological consequences. Chronically reduced caloric intake often leads to metabolic adaptation, in which basal metabolic rate decreases, energy expenditure drops, and the body increases hunger signaling. Hormones such as leptin, ghrelin, and cortisol are altered, creating a biological environment that resists further weight loss. Over time, repeated cycles of dieting, weight loss, and regain, sometimes called yo-yo dieting, have been associated with increased risk for cardiovascular disease, insulin resistance, and alterations in fat distribution. These patterns are not due to personal failure, they are predictable responses rooted in human evolutionary biology. Moreover, chronic restriction can impact reproductive hormones, bone density, and even immune function, demonstrating that the body prioritizes survival over aesthetics. Understanding these consequences underscores why simplistic or extreme diet strategies are often ineffective or harmful. Biology imposes boundaries that culture, advertising, and ideology cannot override. Yet even with this knowledge, the public continues to be influenced by sensationalized diet trends, emphasizing the importance of translating biological evidence into practical guidance that both supports health and respects human physiology. Emerging evidence from large-scale nutrition studies provides a more comprehensive understanding of diet, health, and disease. Longitudinal cohort studies, involving tens or hundreds of thousands of participants across decades, have revealed patterns that single short-term experiments cannot capture. For instance, research shows that dietary patterns emphasizing whole, minimally processed foods, fruits, vegetables, legumes, nuts, whole grains, and lean proteins are consistently associated with reduced risk of cardiovascular disease, type 2 diabetes, and mortality. Conversely, high consumption of ultra-processed foods correlates with inflammation, metabolic dysregulation, and obesity. Importantly, these studies account for variability in genetics, lifestyle, and socio-economic status, providing a nuanced picture that aligns with biological principles rather than simplified calorie-based messaging. Findings also highlight the importance of dietary diversity, fiber intake, and the role of gut microbiota in long-term health outcomes. For scholars, these studies demonstrate that rigorous, evidence-based research must inform dietary recommendations, bridging the gap between biological mechanisms, public health, and individual behavior. But while large-scale research clarifies the science, translating these findings into practical, sustainable habits remains a challenge in a culture still influenced by diet myths. Despite the clarity offered by evidence-based research, the translation of large-scale study findings into everyday behavior is often hindered by persistent misconceptions. Popular diets frequently promote rigid restrictions or eliminate entire food groups, ignoring the complexity of hormonal responses, microbiome interactions, and metabolic adaptation. For example, low-carbohydrate diets may achieve rapid short-term weight loss but often lead to compensatory hunger and changes in energy expenditure that undermine long-term adherence. Similarly, low-fat fads neglect the importance of fats in hormone production, brain function, and satiety regulation. Evidence suggests that flexibility, nutrient variety, and attention to internal hunger cues yield better long-term outcomes, but these principles are less attention-grabbing than promises of rapid transformation. For scholars, understanding these pitfalls reinforces the importance of teaching nutrition as a biological science, not a cultural trend. It also illustrates how diet culture has historically prioritized appearance over physiology, a theme that continues to influence both individual health and public perception. Yet, as we examine emerging approaches in nutrition, it becomes clear that science is beginning to reclaim the conversation from myths and oversimplifications. Technological advances in research methodology are revolutionizing nutrition science, providing new insights into the interaction between biology and diet. Tools such as metabolomics, genomics, and microbiome sequencing allow scientists to observe how nutrients, metabolism, and gut bacteria interact on an individual level. These technologies reveal that responses to the same foods can vary dramatically between people, influenced by genetics, microbiota composition, and environmental factors. Large-scale interventions now consider personalized nutrition, moving away from one-size-fits-all advice. This approach acknowledges that biology dictates individualized responses to diet, explaining why conventional low-fat or low-carb strategies may fail for some. Integrating these technologies into practical frameworks offers the potential for more effective, sustainable dietary guidance, bridging evolutionary principles, hormonal regulation, and microbial science. However, the challenge remains: how can these sophisticated insights be communicated and applied in everyday life without creating confusion or perpetuating myths? Globalization and food marketing further complicate the landscape. Highly processed, convenience-oriented products dominate the shelves in many countries, often engineered to maximize palatability and caloric density. Despite biological feedback mechanisms, these products can promote overeating and disrupt gut microbiome balance. Additionally, advertising often frames foods as good or bad, encouraging restrictive behaviors that may conflict with natural metabolic regulation. This creates a cycle where biology, psychology, and culture interact in ways that make sustainable nutrition difficult for many individuals. Scholars studying diet culture must consider these systemic factors alongside physiological mechanisms, as ignoring the broader environment provides an incomplete picture of why diet patterns succeed or fail. Even as research grows more sophisticated, society's exposure to conflicting messages continues to challenge the adoption of evidence-based dietary practices. Yet, understanding these pressures is essential because it reveals the full context in which biology, behavior, and global food systems converge. Long-term physiological consequences of modern diet culture are becoming increasingly apparent through population studies. Repeated cycles of restrictive dieting and weight regain can alter metabolic flexibility, insulin sensitivity, and fat distribution patterns. Hormonal shifts, particularly in leptin and ghrelin, may persist beyond the dieting period, predisposing individuals to future weight gain. Bone density and reproductive function can also be compromised by chronic energy restriction, highlighting that the impact of diet extends beyond aesthetics to fundamental health outcomes. Furthermore, the stress associated with societal pressure to conform to body ideals triggers cortisol elevation, which influences energy storage and appetite. By considering these physiological realities, scholars can appreciate why certain strategies fail repeatedly and why sustainable approaches must align with biology rather than societal expectation. However, translating this understanding into actionable public health guidance requires careful interpretation of large-scale studies and emerging biological insights. Emerging evidence from population-level research emphasizes the effectiveness of dietary patterns rather than isolated nutrients or restrictive regimens. For instance, studies of the Mediterranean, and Nordic diets consistently show improvements in cardiovascular health, metabolic regulation, and longevity. These dietary patterns share common features: high intake of whole foods, ample fiber, moderate protein, and healthy fats, as well as minimal ultra-processed foods. They demonstrate that sustainable nutrition relies on integration with biology, respecting hormonal feedback, microbiome interactions, and metabolic needs. Additionally, interventions that promote flexibility and gradual behavior change show better adherence and long-term results than rigid restriction. By analyzing these findings, scholars gain insight into how diet culture can be reshaped to reflect biological reality. Yet, even with clear evidence, societal pressures, marketing, and cultural ideals continue to challenge widespread adoption, underscoring the complexity of achieving meaningful change in human eating behavior. The convergence of biological understanding, global nutritional research, and long-term evidence-based frameworks points to a fundamental truth: human nutrition cannot be separated from physiology. Hormones, microbiomes, evolutionary adaptations, and societal influences all interact to determine how the body responds to food. Diet culture, with its obsession on appearance and restriction, often ignores these interactions, leading to frustration, metabolic disruption, and health consequences. Evidence-based approaches that prioritize nutrient quality, biological cues, and sustainability provide a path forward. They respect the body's evolved systems while addressing modern environmental and social challenges. This integrated perspective represents the next stage in nutrition science, a movement away from myths and fads toward a framework grounded in biology, history, and evidence. But even as we embrace these principles, the question remains: how will modern society, with its abundance, technology, and persistent cultural pressures, reconcile these biological truths with daily eating behavior? The next chapter of our documentary will explore precisely that, diving into the final phase of diet culture in the 21st century and what it means for the future of human health. Modern humans face unprecedented challenges in balancing biology with global food availability. Unlike our ancestors, who relied on seasonal, locally sourced foods, today's populations live in environments with constant access to calorie-dense, highly processed foods. This abundance interacts with the body's evolutionary adaptations, which were designed to survive scarcity, not excess. Hormonal systems like leptin and ghrelin, which regulate appetite and energy balance, respond as if food scarcity were still a threat, often leading to overconsumption despite abundant energy stores. At the same time, urban lifestyles, sedentary work, and disrupted circadian rhythms further complicate metabolic regulation. These environmental factors, when combined with the body's natural defenses, create a biological tension that makes weight management, nutrient balance, and metabolic health a constant challenge. Scholars studying diet culture must understand that these challenges are not individual failures but predictable consequences of biology interacting with modern abundance. Yet even as we recognize these pressures, science is developing ways to address them, moving toward individualized strategies that respect the body's unique physiological and biochemical responses. Personalized nutrition is emerging as a powerful approach to address the variability in how humans respond to diet. Research shows that identical diets can produce different metabolic, hormonal, and microbiome responses in different individuals. Factors such as genetics, gut microbiota composition, hormone levels, and lifestyle all influence how the body processes food. Personalized nutrition aims to integrate these factors, using data from genetic tests, blood panels, and microbiome analyses to tailor dietary recommendations to individual biology. Studies demonstrate that personalized approaches can improve glycemic control, optimize weight management, and enhance metabolic efficiency compared to one-size-fits-all dietary advice. This represents a significant shift from the early days of diet culture, which relied on rigid, generalized rules that often clashed with human physiology. By embracing individual variation, personalized nutrition reconciles evolutionary biology with modern dietary environments. However, while the science is promising, translating complex biological data into practical, sustainable eating habits remains a challenge, especially for the general population. Psychological and social factors play a central role in modern diet culture. Beyond biology, humans are influenced by societal norms, media messages, and peer behavior. Cultural ideals of beauty, weight, and health shape perceptions of the ideal body, often creating pressure to adhere to restrictive or unsustainable diets. This pressure interacts with biology in profound ways. Chronic stress elevates cortisol, which can increase appetite, promote fat storage, and disrupt insulin regulation. Moreover, social reinforcement of dieting behaviors can normalize extreme restriction, perpetuating cycles of weight loss and regain. Psychologists studying these phenomena emphasize that effective nutritional strategies must account for both physiology and the mental and social context in which eating occurs. Education about hormonal responses, metabolism, and microbiome interactions can empower individuals, but addressing societal pressures is equally critical to achieving lasting health outcomes. As the research continues, scholars are uncovering strategies to mitigate these pressures while aligning diet with biology. Yet while awareness is growing, widespread adoption of evidence-based approaches remains uneven, leaving gaps in public understanding and behavior. Case studies of successful, evidence-based dietary interventions demonstrate the power of integrating biology, behavior, and environment. For example, longitudinal studies of Mediterranean and Nordic diet patterns reveal that populations adhering to whole food-based, flexible, and culturally appropriate diets experience lower rates of cardiovascular disease, obesity, and metabolic dysfunction. These interventions emphasize nutrient-rich foods, balanced macronutrients, and consistent dietary patterns rather than rapid restriction. Similarly, structured weight management programs that incorporate behavioral therapy, education on hunger and satiety cues, and monitoring of metabolic markers show sustainable outcomes. Importantly, these approaches align with the body's evolutionary adaptations, respecting hormonal and microbiome dynamics instead of attempting to override them. By examining these case studies, scholars can observe that diet success depends on the interaction of biology, environment, and behavior, rather than mere willpower or adherence to fads. Yet, even with clear evidence, translating these principles to diverse global populations continues to present challenges, as culture, accessibility, and food systems vary widely across regions. One striking example of an evidence-based approach is the DASH diet, developed to reduce hypertension through controlled sodium intake and emphasis on fruits, vegetables, whole grains, and lean proteins. Clinical trials show that this approach not only improves blood pressure but also enhances metabolic health and supports microbiome diversity. Unlike restrictive fad diets, DASH encourages flexibility and consistency, helping participants develop sustainable habits. Another case involves workplace interventions providing access to nutrient-dense foods, education on portion sizes, and guidance on mindful eating. Participants in these programs consistently demonstrate improved metabolic markers, reduced weight fluctuations, and higher adherence to long-term health goals. These findings reinforce the principle that nutrition strategies succeed when they integrate biological knowledge with practical environmental support. However, implementing such interventions on a larger societal scale requires coordination between policy, education, and food systems, highlighting the ongoing challenge of translating science into widespread behavioral change. Emerging technology continues to reshape our understanding of diet and biology. Continuous glucose monitors, wearable devices, and metabolic tracking tools allow individuals to observe real-time responses to food, exercise, and stress. This data demonstrates the variability in glycemic responses, hormone fluctuations, and energy expenditure between individuals. Personalized feedback empowers people to adjust eating patterns in alignment with their physiology rather than following rigid rules. Additionally, advances in microbiome sequencing reveal how specific foods influence gut bacteria, which in turn affect metabolism and appetite regulation. Integrating these technologies into daily practice allows evidence-based nutrition to move beyond general recommendations and toward individualized strategies. Yet, while these tools offer promise, their effectiveness depends on education, access, and the ability to interpret complex biological data, a challenge that remains a barrier for broad public adoption. Societal pressures around appearance, weight, and health continue to influence eating behavior in profound ways. Even as research clarifies the biological complexity of appetite regulation, hormonal adaptation, and microbiome interactions, cultural ideals persist. Media portrayals of thinness, perfection, and rapid transformation reinforce restrictive dieting patterns, often creating psychological stress and distorted body image. Studies demonstrate that exposure to diet culture can trigger disordered eating behaviors, cycles of restriction and rebound, and metabolic disruption, especially when biological feedback mechanisms are ignored. By integrating social science with nutrition biology, scholars can better understand the dual pressures individuals face, the internal pull of physiology and the external push of societal expectation. Addressing both factors is critical for sustainable dietary change. Yet despite awareness of these dynamics, misinformation and oversimplified diet messaging continue to dominate public discourse, highlighting the gap between science and practice. Case studies of intervention programs demonstrate the potential for positive outcomes when evidence-based strategies are applied in real-world contexts. Community nutrition programs emphasizing whole foods, education about hunger and satiety, and gradual lifestyle adjustments achieve higher long-term adherence than restrictive or one-size-fits-all approaches. Similarly, clinical trials incorporating personalized nutrition, metabolic monitoring, and behavioral support show that participants maintain weight loss and improve health markers over years. These examples illustrate that sustainable dietary change is possible when interventions respect biology, account for behavior, and provide environmental support. For scholars, these case studies are invaluable, as they demonstrate the principles of successful nutrition in action and provide a roadmap for future research and policy implementation. Yet, as effective interventions exist, the challenge remains: how can society scale these approaches while counteracting pervasive myths, marketing pressures, and cultural norms that continue to influence eating behavior worldwide? Large-scale nutrition studies reinforce the lessons from case studies, demonstrating that population-wide health improvements require strategies that integrate biology, behavior, and environment. Research shows that countries adopting dietary patterns rich in whole foods, fiber, and balanced macronutrients experience reductions in obesity, diabetes, and cardiovascular disease, even when calorie availability is high. Conversely, reliance on ultra-processed, low-nutrient foods correlates with metabolic disruption, inflammation, and poor long-term outcomes. These findings underscore the importance of understanding biological feedback mechanisms, hormonal regulation, and microbiome interactions when designing public health recommendations. Education, policy, and access to nutrient-rich foods are all necessary to translate scientific evidence into meaningful change. Yet, despite clear evidence, the gap between biology-based recommendations and public behavior remains significant, highlighting the enduring influence of culture, marketing, and perception on diet. The final lesson of this chapter is clear: sustainable nutrition must reconcile human biology with environmental and societal realities. Evidence-based approaches that respect hormonal regulation, metabolic adaptation, and microbiome activity, while addressing social pressures and global food availability, represent the most promising path forward. Historical diet fads and contemporary myths often fail because they ignore these biological truths. By studying population data, clinical interventions, and individual variability, scholars can identify strategies that are both scientifically sound and practical. Yet, as we move into the last 10 minutes of our documentary, a new question emerges: how can humans apply centuries of biological understanding in a world of abundance, technology, and cultural pressure to achieve long-term health and well-being? The answers lie in the final phase of our exploration, where history, biology, and practical guidance converge to illuminate the future of diet culture. As we enter the final phase of this exploration, it becomes clear that understanding diet culture requires synthesizing historical, biological, and cultural insights. From ancient civilizations observing the relationship between food and health, to early modern diet fads, to today's evidence-based frameworks, patterns emerge. Biology has remained constant. Hormones, metabolism, and the microbiome govern how humans respond to food, but societal perception, availability of food, and marketing narratives have shifted dramatically. Historical restrictions, religious fasting, and early nutritional theories reveal that culture has always influenced how humans approach eating, sometimes in ways that align with biology, but often in ways that conflict with it. By integrating these perspectives, scholars can trace why restrictive dieting persists, why body image ideals shape behavior, and why certain biological mechanisms, like metabolic adaptation, consistently challenge long-term adherence. This holistic understanding is critical. It shows that diet culture is not just a personal or social phenomenon, but a complex intersection of evolution, physiology, and environment. Yet even with this clarity, the pressing question remains: how can individuals navigate this landscape in a way that honors their biology while living in a modern world overflowing with choice? First, focus on nutrient-rich, minimally processed foods, vegetables, fruits, whole grains, legumes, nuts, and lean proteins, which support metabolic balance, hormonal regulation, and gut health. Second, recognize the importance of satiety cues. Eat slowly, monitor hunger and fullness, and allow flexibility rather than strict restriction. Third, consider macronutrient balance. Sufficient protein supports muscle mass, complex carbohydrates fuel the brain, and healthy fats are essential for hormone synthesis. Fourth, integrate variety and cultural preference, which enhances adherence and microbiome diversity. Finally, combine nutrition with lifestyle factors such as regular physical activity, adequate sleep, and stress management, all of which influence hormonal regulation and appetite. These strategies are not quick fixes, they are consistent, biology-aligned practices that respect both evolutionary adaptations and modern realities. While this approach may seem gradual compared to the promise of fad diets, research demonstrates it is far more effective for long-term health. Yet, the challenge remains: how do these strategies translate to individual variation, which is one of the most fascinating frontiers in nutrition science? Lessons from evolutionary biology offer profound guidance for modern eating. Human physiology evolved to survive fluctuating food availability, requiring energy conservation during scarcity and efficient storage when food was abundant. Today, our environment has shifted dramatically, but our biology has not. This evolutionary perspective explains why hyperpalatable foods can override satiety, why periods of restriction trigger intense hunger, and why weight loss is often followed by regain. By embracing these biological truths, individuals can approach nutrition with realistic expectations. Strategies that mimic ancestral eating patterns, such as consuming whole, minimally processed foods, maintaining regular meal timing, and engaging in natural physical activity, support hormonal balance and metabolic health. Importantly, evolutionary biology also emphasizes flexibility and moderation. Extreme restriction is unnatural, whereas consistent, nutrient-rich eating aligns with the body's design. Scholars can appreciate that these lessons are not theoretical, they are grounded in physiology, hormone signaling, and metabolic feedback. Yet, while evolution provides guidance, humans must still navigate modern challenges like global food abundance, marketing influences, and cultural ideals. Modern diet culture is at a crossroads, influenced by technology, global food systems, and cultural pressures, but also increasingly guided by science. Wearable devices, continuous glucose monitors, and microbiome testing allow unprecedented personalization of diet, revealing how individuals respond uniquely to the same foods. Large-scale studies confirm that nutrient quality, dietary diversity, and behavioral support consistently outperform restrictive trends in improving health outcomes. Simultaneously, public awareness of hormonal regulation, metabolic adaptation, and microbiome dynamics is increasing, creating opportunities to counteract myths and fad diets. For the first time, there is the potential to align societal messaging with biological reality. Yet, technology and evidence alone cannot solve the problem. Behavior, culture, and access to nutrient-dense foods continue to shape outcomes. The question now becomes how science, education, and policy can converge to create a society in which sustainable nutrition is achievable for the majority, not just a privileged few. Case studies from clinical research and public health interventions provide practical examples of what works. Community-based programs emphasizing whole foods, gradual lifestyle adjustments, and education about hunger cues have demonstrated lasting health improvements. Personalized nutrition interventions, incorporating genetic, hormonal, and microbiome data, show improved weight management, metabolic markers, and adherence. National-level policies that increase access to nutrient-rich foods while reducing ultra-processed products further illustrate the importance of environment in supporting biology-aligned eating. These successes emphasize the principle that sustainable nutrition depends on integration, aligning biology, behavior, and environment, rather than relying on willpower alone. Scholars examining these interventions can observe the importance of consistent, flexible, and culturally sensitive approaches. Yet, as effective strategies emerge, the tension between biology and modern societal pressures remains, illustrating that education and awareness are just as critical as scientific innovation. Psychological and social factors remain central to the long-term success of evidence-based nutrition. Stress, body image ideals, and cultural expectations can disrupt hormonal balance, increase cortisol, and undermine dietary adherence. Mindful eating, education about hunger and satiety, and support networks are essential components of sustainable strategies. Behavioral approaches that emphasize gradual habit formation, rather than extreme restriction, respect the body's evolved mechanisms while promoting psychological well-being. Furthermore, understanding that weight fluctuations and hunger are natural biological responses reduces guilt and frustration, encouraging sustainable habits. Scholars recognize that addressing these social and psychological dimensions is as critical as understanding metabolism, microbiome composition, or nutrient balance. Yet even with these insights, humans must still navigate a global food environment designed to exploit our biology, posing one of the greatest modern challenges to health and nutrition. The future of diet culture and nutrition science lies in synthesis, combining biological understanding with practical strategies and societal support. Technology will allow increasingly personalized interventions, while public health initiatives can guide behavior at a population level. Education grounded in hormonal regulation, microbiome science, and evolutionary biology empowers individuals to make informed choices. Evidence-based dietary frameworks demonstrate that flexible, nutrient-dense, and culturally appropriate patterns outperform restrictive diets in promoting long-term health. The integration of these approaches creates a new paradigm, one in which diet culture shifts from obsession over weight and appearance to a focus on sustainable health, metabolic efficiency, and psychological well-being. Scholars can see that this evolution is rooted in centuries of observation, experimentation, and research, demonstrating the power of biology-informed guidance in shaping human behavior. Yet, despite this promise, challenges remain in ensuring access, cultural adaptation, and adherence across diverse global populations. Modern nutrition is no longer solely about restriction or aesthetic goals, it is about alignment with biology. Hormonal regulation, metabolic adaptation, and microbiome interactions dictate how humans respond to food, and these factors must inform dietary strategies. By prioritizing whole foods, balance, and flexibility, individuals can respect their physiology while thriving in a modern environment of abundance. Personalized approaches offer further refinement, tailoring diets to individual metabolic and microbiome profiles. Large-scale research demonstrates that consistent, nutrient-rich eating patterns reduce disease risk, improve metabolic health, and enhance longevity. Integrating these insights bridges the gap between historical diet culture, modern challenges, and biological realities, providing a roadmap for sustainable nutrition. Yet, even with this knowledge, the question remains, how will society balance convenience, abundance, and cultural pressures with the lessons of biology to create a healthier global population? The final lessons from this journey are clear: sustainable nutrition is achievable, but only through integration. Evidence-based frameworks that consider evolutionary biology, hormonal systems, microbiome interactions, and psychological and social factors provide a path forward. Education is critical. Individuals must understand how their bodies respond to food, why restriction often fails, and how flexibility promotes long-term adherence. Environmental support, policy, and access to nutrient-rich foods further enable sustainable habits. Case studies and population research consistently show that approaches respecting biology outperform fad diets in health outcomes. For scholars, this synthesis demonstrates the importance of a multidisciplinary understanding of nutrition. Biology, history, culture, and behavior all contribute to outcomes. Yet, as we conclude, one final challenge remains: how will future generations apply these lessons to overcome the persistent myths, pressures, and environmental factors that have historically shaped diet culture? In conclusion, the story of diet culture is a story of biology meeting society. From ancient observations to modern molecular science, from fad diets to evidence-based interventions, one principle remains: human physiology is neither simple nor easily overridden. Hormones, metabolic adaptation, and the microbiome govern our response to food, while cultural ideals, marketing, and global food systems shape behavior. Sustainable nutrition emerges when humans align eating patterns with these biological realities, integrating flexibility, whole foods, and personalized approaches. The future of diet culture lies in education, scientific innovation, and societal adaptation, ensuring that individuals can thrive in an environment of abundance while respecting the evolved systems within them. For scholars, the lesson is profound. Understanding nutrition requires history, biology, psychology, and cultural awareness, all working together. And with this knowledge, the promise of a healthier, more sustainable approach to eating is not just a theory, it is a roadmap grounded in science, waiting to be followed. Now, if this video has helped you understand diet in a better light, don't forget to like, comment, share, and subscribe for more contents like this.